we looked at this polynomial, and what I'm going to ask you is find all the zeros. Okay? Find every single one of the zeros. I haven't given you any zeros yet. Right? So far, we worked on, hey, here's a zero, or here's a factor. And then you can apply synthetic division or long division. Here, I haven't given you any information. I just say, hey, find all the zeros. So there's a couple ways that we can do this. Well, you can look into factoring it. You could go ahead and do that, and then we could see, now, could you factor it, though? Is it factorable? Now, you could see, well, you could look try to factor by grouping, right, and see if it works. But in this case, if you get a stumbling block, I don't see that I can be able to factor this by grouping, right? So I'm kind of getting stuck. So there's a couple things that we can do. One, we can always go back to that rational zero test that I talked about, where we look at our p and our q. So here, when we're taking the plus or minus the p over the q, what you guys have is 10 over the plus or minus the factors of 10 over 1. So again, let's look at the factors of 10. We have 10, 1, and 5 and 2, right? So we'll have 10, 5, 2, 1. And then it's nice when we have a coefficient of 1, because we know the only factor of coefficient of 1 is just going to be over 1. So the number of possible real zeros, and I'll write this over here. So the possible real zeros, and this is going to be like our bank, what we're going to be able to deal with, or what we're going to have to choose from. So our possible real zeros are going to be plus or minus 10, 5, 2, and 1. That means if we have a rational zero, it's going to be one of those numbers. All right? So now let's go to the next one. That was Descartes' rule, or that was the rational zero test. The next thing is we can apply Descartes' rule of signs. And I'll try to make these a little bit quicker. If we bring down our signs, positive, negative, positive, negative. Right? So we have 1, 2, 3, right? 2, 3 alternating signs. So by looking at Descartes, or this would be postulatal, sorry, that's not real, it's rational. So if we're looking at the real zeros, we have a possibility of 3 or 1, because remember, you subtract an even number. Yes? There's 3 alternating signs, and then subtract an even number of 2. Question? OK. So you have your alternating signs. Remember, I just brought down the signs of my monomials, brought them down, and I have 3 or 1. And then if we determine f of negative x, I have negative x cubed minus 6, negative x squared, plus 13 times negative x minus 10. So therefore, negative x cubed, that becomes positive, negative 6x squared, minus 13x minus 10. And you can see, is there any alternating signs? Yes?
Wouldn't the negative x, wouldn't that be positive because it's cubed?
This one?
Yes.
Well, think about it. Just do negative. OK. So you guys can see, is there any zeros here? Or any negative zeros? No. So the number of negative is 0. All right? So here comes the question of the day. All right? I have this polynomial, or this function, polynomial function. I have not given you the 0. All I've given you is a couple tests to help you determine the possible zeros. The only thing we know right now is we know that there's 3 positive or 1 positive, and there's no negative. And if it is rational, it's going to be one of these numbers. All right? So let's pretend it is one of these numbers. Jessica, do you remember, how can we determine if, let's say, number 5 is a 0? How can we determine if 5 is a 0? You want to apply what? The what? Yes, you can apply zero product property. But so how are we going to get to that quotient to apply zero product property? We want to use a division technique to make sure it divides into there with the remainder of 0. So our division that we've used is synthetic, right? Not authentic, but it's been synthetic. So what you could do, and I'm going to kind of go through this process, because, ladies and gentlemen, I've told you when we started in this class, as far as our graphing technology, is if you don't have your graphing technology, we need to choose. We need to determine which one of these are the case. Now, what's been helpful about Descartes' zero signs, Will, is that do we know we have to, do we have to do plus and minus for all these? Or do we just have to do the positive? Because the negative, there is no negative, right? We know there's no negative real zero. So guess what? Let's just worry about the positive, all right? Now, ladies and gentlemen, if I don't have graphing technology, guess what I'm doing? I now have to apply synthetic division for every one of those zeros until I find one. Now, it's nice that I don't have to do the negative, because now I can just do the first two zeros, 1 and 2. I'm not going to go crazy. I'm going to do the easy ones as much as I can, right? Then I'll work up to harder numbers. I don't want to do fractions. Fortunately, we don't have any actual fractions dealing with this. But you know, if you have like 2/3, you're going to want to do synthetic division with the number 1 before you do synthetic division with 2/3, right? Even though we did practice it. So let's do a quick little synthetic division. Bring down 1. 1 times 1 is 1. That becomes a -5. -5 times 1 is -5. That's going to be 8. 8 times 1 is 8. -2. So therefore, is 1 a 0? No. No, it's not. Yes?
If I factor it back, don't have to do that, right?
I'll talk about it in just a second. So now we go into 1. Bring down the 1. 1 times 2 is 2. -4. -8. 5. +10. 0. Therefore, we now have a remainder, constant, linear, and quadratic. So therefore, you have x squared minus 4x plus 5. Now, getting back to you, Jessica. So now we have our remaining quotient factor, right? Our remaining quotient factor. So therefore, to find the remaining zeros, we know that this is a factor. So yes, we can apply the zero product property by setting it equal to 0. And then how are we going to solve this? By all those worksheets I've given to you. You're going to have to, Samantha, do what? Factor, right? So therefore, you factor this. What is that? I'm thinking of -5. But it's a +5. Not factoring? OK. Ladies and gentlemen, if you have trouble with the factoring problem, all right? Now remember, we said there's a possibility of 1 real 0 or 3, right? There's a possibility of 1 or 3. So therefore, this factor of 2, or the factor of x minus 2, that's the factor, and the 0 would be x equals 2. That means that could be the only one. So if you only have, you have no zeros or no negative zeros, you have 1 positive, what are the other 2 must be? What other type of numbers can we have? Imaginary, right? They're going to be 2 imaginary zeros. So let's just go ahead and confirm this by quadratic formula. So if I take plus or minus 4 minus the square root of 4 squared minus 4 times 1 times 5. So we have 16 minus 20 divided by 2 times a, which is 1, divided by 2. So therefore, equals x. Let's get this. So we have 4 plus or minus the square root of -4 over 2 equals x. 4 plus or minus 2i over 2 equals x. So therefore, x equals 2 plus or minus I. So there we go, ladies and gentlemen. You do see that you have 2 more variables, or I'm sorry, 2 more zeros, but they're not real, right? They're complex. OK? So that's how you're going to do it if you do not have a graphing technology. What I'm going to recommend to you guys